Okay, this is part 2 of systems of equations. Now we're going to talk about another method for solving systems. Solving systems of equations in two variables by the addition method. So the first thing we're going to do is we're going to write both equations with x and y variables on the left side of the equal sign and constants on the right. Once we do that, we're going to write one equation above the other, lining up corresponding variables. If one of the variables in the top equation has the opposite coefficient of the same variable in the bottom of the equation, we can just add the equations together and that will eliminate one of the variables. Because if you think about it, if the coefficients are the same but opposites, like 2 and -2, then that would cancel when you add them together. If they're not the same but opposites, then you're going to use multiplication by a non-zero number so that one of the variables in the top equation has the opposite coefficient of the same variable in the bottom equation. Then we can add the equations to eliminate the variable. Once we do that, we're going to solve the resulting equation for the remaining variable. Then we'll substitute that value into one of the original equations and solve for the second variable, and then we'll check our solution. Okay, so let's look at this example. Solve the given system of equations by the addition method. So first we're going to check to see if either of the variables have the same coefficients but opposites. So for the x's, they're already lined up. The x and y is already on the left. The coefficient of the top x is 5, the bottom is 1, so they're not the same. Neither is the 9 or the 2. So what we can do is we can multiply one or both of these equations so that we can make the coefficients of one of the variables the same but opposite. And I think the easiest one to do would be to do the x, because I can make a 1, a 5, or a -5 by multiplying by -5. So I'm going to multiply both sides of the second equation by -5, and I get -5x, you have to distribute, minus 10y equals -20. So you're multiplying everything by -5. And then we can bring over the original top equation because we didn't do anything to it. Now you can multiply both by different numbers, but we only had to multiply one. So now once we do this, we're going to add together these equations. So when I add 5x and -5x, they cancel. 9y minus 10 is -1y equals 16 minus 20 is -4. So we'll divide both sides by -1 and we'll get y equals 4. So that's one of them. Now we're going to take the y equals 4 and sub it into one of the original equations and solve. So I'll just take the second equation, x plus 2y equals 4. And instead of the y, I'm going to replace it with what we said y equals. And we said y equaled 4. And we're going to solve that. So that's x plus 8 equals 4. Subtract 8 on both sides, and we get -4. Now we have an x and a y, so we can always check our solution at the end. So we'll rewrite the top equation, and we'll rewrite the bottom of the equation. And then everywhere we see an x, we will put -4. And everywhere we see a y, we'll put -4. So x was -4. And everywhere we see y, we put +4. Okay, 5 times -4 is -20. Plus 9 times 4 is 36. Does that equal 16? It does. -4 plus 8 equals +4. That works too. So that means our answer is -4, 4. Alright, moving on. Your turn. You guys try to solve this system by the addition method. Pause the video, work the problem, and when you'll come back, we will go over how to do it. Okay, so hopefully you had time to work the problem, and I'm looking at both equations. The variables are already on the left, and they're lined up. So I can make the 2 and the 3 the same by making them both 6s. I can multiply the top by 3 and the bottom by -2. Or I think what would be easier is I could multiply that bottom equation by 7 on both sides, because that will make that a positive 7, which will cancel with the negative 7. So I'm not doing anything to the top equation. It stays 2x minus 7y equals 2. But my bottom equation is going to become 21x plus 7y equals negative 140. Okay, so 2x plus 21x would be 23x. The 7 and negative 7y cancel, equals negative 138. If I divide both sides by 23, that leaves negative 6. Okay, so now we'll take the negative 6 and put it in for x. You can go into either equation. So I'll go into the top equation. So 2x minus 7y equals 2. I'm replacing the x with negative 6. And I get negative 12 minus 7y equals 2. If I add 12 to both sides, I get negative 7y equals 14. When I divide both sides by negative 7, I get negative 2. So it looks like the answer is negative 6, negative 2, but you'll want to check and make sure. So 2 times x minus 7 times y should equal 2, and 3 times x plus 1y should equal negative 20. And we're putting in negative 6 for the x's, and we're putting in negative 2 for the y's. So 2 times negative 6 is negative 12. Negative 7 times negative 2 is positive 14. When you add them together, they do equal 2. 3 times negative 6 is negative 18. Plus negative 2 does add up to be negative 20. So we are correct. So this would be our answer, our solution. Alright, so you guys try another one. Try this one, pause the video, come back, and we'll go over it. Okay, so for this one, it looks like the variables are already lined up for us. We have 2 and 3 for the x's, 3 and 5 for the y's. So then you just need to pick one. 2 and 3 will both go into 6. So I could multiply the top by 3 to make it positive 6, and the bottom by negative 2 to make it negative 6. You could also multiply the top by negative 3 or the bottom by positive 2. Where the negative is doesn't matter as long as one of them is a different sign. So the new top equation would be 6x plus 9y equals 24. The new bottom equation would be negative 6x minus 10y equals negative 20. So we're going to add together. The x's cancel. We get negative y equals 4. If we divide both sides by negative 1, we get negative 4. Now we'll take one of the original equations. I'll just take the top equation. 2x plus 3y equals 8. And y we're saying is really negative 4. So 2x minus 12 equals 8. So we'll add 12 to both sides, and we'll get 2x equals 20. If we divide by 2, we get x equals 10. So it looks like the answer is 10 and negative 4, but we want to check both equations to make sure. So 2x plus 3y should equal 8, and 3x plus 5y should equal 10. And our answers were 10 and negative 4. So 2 times 10 is 20. 3 times negative 4 is 12. 20 and negative 12 is 8. That works. 3 times 10 is 30. 5 times negative 4 is negative 20. When you add those together, that does become negative 10. So it looks like this is our answer. Okay, so here's another one. Let me do this one with you. So we've got the y's and the x's lined up. And it looks like they're the same variable, but they're the same sign. So I'm just going to multiply this bottom times a -1. And so I get 2y minus 2x equals 2 on top because I didn't do anything to it. On the bottom, I have -2y plus 2x equals -6. So when we add these together, the y's cancel and the x's cancel. That leaves nothing on the left. On the right, we have 2 minus 6, and we get -4. So what does this mean? Because we didn't solve for x. So what this means is there is no solution. That's what that means. So if all variables cancel, then look at the remaining statement. If it is false, then that means we have no solution. And let me go back in the PowerPoint and show you what that looks like graphically. Because if you'll remember, there were different types of solutions. So graphically, it looks like this. It's an inconsistent system. It's an inconsistent system because the lines never intersect. It's inconsistent. Now, if we cancel out all the variables and we're left with a true statement, then that would be a dependent system, which means that the lines, the two lines are actually the same line. They're actually the same line. So going back to the bottom here, where were we? So if you have a true statement, then you have infinite solutions because they cross at every single point. You have coinciding lines. Okay, so another try it. So solve this problem, pause the video, solve it, and come back and we'll go over it. Okay, so this equation you can solve by substitution or by the addition. So it's really up to you. I think just because we haven't solved one this way in a little while, I'm going to do substitution. So I'm going to solve this top equation for y, and I get y equals 2x plus 5 because you would add 2x to both sides, and I'm going to sub it in to this y here. So we have -3y plus 6x equals -15, and I'm going to replace the y with 2x plus 5. And then it's distribute and solve. So -6x minus 15 plus 6x equals -15 rather. The 6x's, they cancel, and that leaves -15 equals -15. So this is a true statement. Notice that the notice that all the variables cancel. That means it's a dependent system. They're coinciding lines. That means there's an infinite number of solutions. Okay, let's look at this example about profits. So there's something called a revenue function, and it's the function used to calculate the amount of money that comes into a business, and it can be represented by the equation R equals XP, where X is quantity and P is price. Then there is a cost function, and that's the function used to calculate the cost of doing business. It includes fixed costs such as rent and salaries, and variable costs such as utilities. Now, if you were to find both of those functions and then graph them, the place where they intersect would be called the break-even point. So revenue, the amount coming in, cost, the amount going out, where they cross, that's where they're going to break even. Okay, so finding the break-even point of a profit function using substitution. So what you can do is you can solve a system to solve for the break-even point. Okay, so they give us two equations, one for the cost, which is C equals 12x plus 30 for a stuffed animal business. So I'm guessing X is the number of stuffed animals that they would need to make. And revenue of function is R equals 20x. So where do they break even? So basically, we're saying this is Y and this is Y, basically, right? So basically what we can do is we can just take this number and sub it in for Y. So we have 20x is equal to 12x plus 30, and we can solve it. So if I subtract 12x on both sides, I get 8x equals 30. So if we divide 30 by 8, we get x equals 3.75. So you would need to make 3.75 stuffed animals to break even. Now, what is the break-even cost? So let's just check and see. If I were to put in the 3.75 here, so 12 times 3.75 plus 30, we would get 75. And then the revenue, revenue is a different equation. It's 20 times 3.75. And that's 75 as well. So the break-even point is 375 and 75. So 3.75 stuffed animals and $75 would be the break-even point. All right, so meal tickets at a circus cost $4 for children and $12 for adults. If 1,650 meal tickets were bought for a total of $14,200, how many children and how many adults bought tickets? So this is not necessarily a formula that you're following, but you're just kind of translating this wording into a number sentence. So meal tickets at a circus cost $4 for children. So I'm going to put 4 X, and X is going to be the number of children. Plus $12 for adults. So I'm going to say Y is the number of adults. And that equals, if you read through the whole thing, the total that the tickets cost were $14,200. Then it says, the other thing it tells us is that there were 1,650 meal tickets total. So if you were to add all of the children plus all of the adults, they sold 1,650. So now we want to solve, so you can decide whether to solve by substitution, by the addition rule, or you can solve using graphing. I think I'm going to do addition. So I'm going to multiply the whole bottom by -4. And I get 4x plus 12y equals 14,200 on the top, because I didn't do anything to that one. On the bottom, I have -4x minus 4y equals negative 6,600, I believe. So then what happens is we cancel the 4's, and that leaves 8y is equal to 7,600. So divide both sides by 8, and you get 950. 950. So then if we go back to one of the original equations, I think I'll just go to the second one because it looks like the easiest one. X plus y is really 950, should equal 1650. If I subtract 950 on both sides, I get 700. So there are 700 child tickets and 950 adult tickets. And you can double check and make sure that this works out. So 4 times x and 12 times y should be that 14,1200. So I have 4 times, what do we get for x? 700 plus the adult tickets were $12, and we said there were 950 of them. And look, we do get 14,200. If we add 700 plus 950, we do get 1650. So it does work out. So these are our answers. All right. Okay, so let's look at one last example. Granola costs $4.50 per pound. Assorted nuts cost $7 per pound. How many pounds of granola and nuts are needed to make 7 pounds of trail mix that costs $5? So we have two unknowns. We have what we'll call X. So this is the number of pounds of granola. And Y will be the number of pounds of nuts. So when we add the number of pounds of granola plus the number of pounds of nuts, it should equal 7 because there were 7 pounds of trail mix. But then if we multiply each of those by its cost, so $4.54 for each pound of granola plus $7 for each pound of nuts, that should equal a total of $5 per pound. There were 7 pounds, so that's actually 35. Okay, so the number, so if you've got $5 per pound, that's $35. So I'm going to replace this 5 times 7 with 35. Okay, so it's up to you how you want to solve. I think I'll just go ahead and use addition. Again, I'm going to multiply the whole bottom times -7. And I end up with -7x minus 7y equals -49. And on the bottom, we don't do anything to that equation. We have 450x plus 7y equals 35. So when we add these together, these 7's cancel. -7 plus 450 is 250. X equals -49 plus 35 is -14. So if I divide everything by -250, let's see, -14 divided by -2.5. Oops, I forgot my decimal. And we get 5.6. So we have 5.6 pounds of granola. So we know that x plus y should equal 7. So 5.6 plus y should equal 7. If I subtract 5.6 on both sides, I get y equals 1.4. So let's double check our equations from the beginning. If I have 5.6 plus 1.4, that does equal 7. If I have 450 times 5.6 plus 7 times 1.4, oops, that does equal 35. So there we have it. There are 5.6 pounds of granola and 1.4 pounds of assorted nuts. All right, so these, it's just reading the number sentences and trying to put them, reading the examples and trying to put them in a number sentence or sentences that make sense. Okay, all right, so that's it. That's everything. So if you have questions, let me know.